Picture this, a cosmic mystery so mind-bending, so jaw-dropping, that it could rewrite everything you thought you knew about reality. What if our universe, every galaxy, every star, every planet, every atom, isn't just floating in some vast void, but is actually trapped inside the most extreme object in existence? A black hole. Yeah, you heard that right. The entire universe, all 93 billion light-years of it, might be nestled inside a colossal black hole. And we're just now starting to unravel the clues. Buckle up, because this is going to be a wild ride through the cosmos, packed with shocking revelations, cutting-edge science, and a touch of existential wonder that'll leave you staring at the stars with your jaw on the floor. Let's start with the basics, because to wrap your head around this insane idea, you need to know what a black hole even is. Imagine a place in space where gravity is so intense, so overwhelmingly powerful, that it warps the very fabric of space and time. Light itself, the fastest thing in the universe, can't escape its grip. All paths through space-time curve inward like water spiraling down a drain. And once you cross that invisible boundary, called the event horizon, there's no turning back. It's not a hole in the traditional sense, like a pit you fall through and pop out the other side. No, this is a three-dimensional trap, a cosmic prison where anything that enters is lost forever to the outside universe. Sounds terrifying, right? But what if this isn't just a quirky feature of distant cosmic monsters? What if this describes the very universe we call home? Now here's where things get really freaky. The universe has its own kind of horizon, a cosmic boundary beyond which we can't see. It's not because there's a wall out there or some cosmic do not enter sign. It's because the universe is only about 13.8 billion years old, and light from beyond that distance hasn't had time to reach us yet. This is called the cosmic horizon, and it's the edge of our observable universe. Here's the kicker. If you take all the mass in the observable universe, every galaxy, every star, every speck of dust, and calculate what size a black hole would be if it contained that much mass, the event horizon of that black hole would be roughly the same size as our cosmic horizon. Coincidence? Maybe. But it's the kind of coincidence that makes scientists sit up and say, "Hold on, what's going on here?" This isn't just a wild guess cooked up by some starry-eyed theorist. The math checks out. The average density of matter in our universe, when you spread it out across the vast expanse of space, matches almost perfectly with the density you'd expect inside a black hole of this size. It's like the universe is whispering, "Hey, maybe I'm not what you think I am." But before you start picturing yourself trapped in some cosmic abyss, let's dive deeper into what this could mean and why it's not as simple as it sounds. First, let's talk about what happens when you fall into a black hole. According to Einstein's general theory of relativity, which is basically the rule book for how gravity and space-time work, something bizarre happens inside a black hole. As you cross the event horizon, the universe behind you, its entire history from the Big Bang to the present, starts to unfold in a weird, compressed way. Meanwhile, in front of you, a whole new space-time opens up. It's like stepping through a cosmic doorway into a new reality. Some physicists have suggested that our universe could be that new space-time, born on the other side of a black hole's event horizon. In other words, our Big Bang, the explosive moment that kicked off everything we know, might have been the moment a black hole formed in some larger parent universe, and we're living in the bizarre new reality that emerged inside it. This idea isn't just a random thought experiment. It's backed by some serious science, and recent discoveries are adding fuel to the fire. Let's talk about one of the most shocking pieces of evidence: the possibility that our universe has a net rotation. You'd expect the universe to be pretty random, right? Galaxies spinning one way, others spinning the opposite, all cancelling each other out. But a groundbreaking study from 2024 observed hundreds of spiral galaxies from the best vantage points, above and below the plane of our Milky Way, and found something wild. About two-thirds of these galaxies were rotating in the opposite direction to our own Milky Way. That's not random. That's a hint that the universe itself might have a net angular momentum, like a giant spinning top. Why does this matter? Because rotation is a big deal in black holes. When stuff falls into a black hole, it doesn't just plummet straight in. It swirls, like water going down a drain, carrying angular momentum with it. That momentum gets preserved in the black hole, and if our universe is inside one, that net rotation could be a clue to how it formed. Think about it. The Big Bang is usually pictured as this perfectly symmetrical explosion, expanding evenly in all directions. But if the universe is spinning, that symmetry breaks down. Where did that spin come from? One possibility is that we're inside a rotating black hole, and the stuff that fell into it billions of years ago set the whole thing spinning, imprinting that motion onto the universe we see today. Let's take a step back and think about how rotation works in the universe. You've seen ice skaters spin, right? When they pull their arms in, they spin faster. That's because of a fundamental law of physics called the conservation of angular momentum. If something is rotating slowly, when it's spread out, it'll spin faster as it contracts. This is why stars, planets, and galaxies all spin. They form from giant clouds of gas that have a tiny bit of motion to start with. And as they collapse under gravity, that motion gets amplified. But here's the thing. Those gas clouds are usually random, with no preferred direction. So if you look at a bunch of galaxies, you'd expect half to spin one way and half the other, cancelling out any overall rotation, finding that two-thirds of them are spinning the same way. That's a cosmic red flag. It's like the universe is telling us it has a history we don't fully understand yet. Now let's get to the heart of why this idea is so emotionally gripping. If we're inside a black hole, it changes everything. It means our universe isn't some standalone bubble floating in nothingness. It's part of something bigger, a nested reality within a larger cosmos. Every star you see, every planet, every moment of your life, it's all happening inside a cosmic structure we can barely comprehend. It's humbling, but it's also awe-inspiring. It's like realizing you're a character in a story that's part of an even bigger book, written in a language we're only just starting to decode. But how could this even work? Let's break it down. Black holes aren't just cosmic vacuum cleaners, sucking everything up. They're gateways to new possibilities. Inside a black hole, the laws of physics as we know them break down, but the math of general relativity suggests that new spacetimes can form. These aren't just abstract equations. They're descriptions of reality. Some models propose that when a black hole forms, it creates a baby universe inside it, connected to the parent universe by a narrow bridge of space-time. Our Big Bang could have been the moment that bridge formed, and everything we know, every galaxy, every particle, emerged from that event. Here's where it gets even crazier. Black holes don't just preserve mass and angular momentum. They also have something called entropy, which is a measure of disorder. The entropy of a black hole is tied to the surface area of its event horizon, not its volume. Guess what? The entropy of our universe, when you calculate it based on the cosmic horizon, looks eerily similar to what you'd expect for a black hole of this size. This isn't just a coincidence, it's a clue that our universe might be governed by the same rules as a black hole's event horizon. Let's talk about the holographic principle, because this is where things get truly mind-blowing. This idea, which has been gaining traction in theoretical physics, suggests that our three-dimensional universe might actually be a projection of information encoded on a two-dimensional surface, like the event horizon of a black hole. Imagine the universe as a hologram, where all the complexity of stars, galaxies, and life is just a reflection of data stored on some cosmic boundary. If we're inside a black hole, that boundary could be the event horizon, and everything we experience is a projection of the information encoded there. It's like living in a cosmic movie theater, where the screen is the edge of the black hole, and where the images flickering across it. This idea isn't just theoretical fluff, it's backed by some of the most advanced physics we have. In 2023, researchers published papers exploring how the holographic principle could explain some of the weird quirks of our universe, like the way dark energy seems to drive its expansion. Dark energy, that mysterious force making the universe expand faster and faster, might be a consequence of living inside a black hole. The math suggests that the expansion we observe could be the result of the black hole's event horizon growing as more mass falls into it from the parent universe. It's a feedback loop that ties our reality to something much bigger. Now, let's address the elephant in the room. If we're inside a black hole, why don't we feel it? Why aren't we being crushed by insane gravity or torn apart by tidal forces? The answer lies in the scale of the black hole. A black hole, with the mass of our universe, would be so enormous that its event horizon would stretch across billions of light years. Inside such a massive black hole, the tidal forces, the stretching and squeezing you'd feel near a smaller black hole, are so weak that you wouldn't notice them. The universe we experience feels flat and normal because the black hole is so vast that its curvature is spread out over unimaginable distances. But there's more. If we're inside a black hole, it could explain some of the biggest mysteries in cosmology. Take the Big Bang itself. We've always pictured it as the ultimate beginning, a single point of infinite density where everything started. But what if it wasn't a beginning at all? What if it was just the moment our universe formed inside a black hole in a larger cosmos? This idea, called the Black Hole Cosmology, suggests that every black hole creates its own universe, and ours is just one of many. It's a fractal-like structure, where universes give birth to more universes, each nested inside a black hole. It's the kind of idea that makes you want to lie down and stare at the ceiling for a while. Let's talk about some of the latest research pushing this idea forward. In 2024, a team of physicists used advanced computer simulations to model what a universe inside a black hole might look like. They found that the conditions inside a rotating black hole could produce a spacetime that looks a lot like our own, with galaxies, stars, and even the cosmic microwave background, the faint glow left over from the Big Bang. Their models showed that the rotation of the black hole could imprint a subtle twist on the universe, which matches the net rotation observed in those spiral galaxies we talked about earlier. It's not proof, but it's a tantalizing hint that we're on the right track. There's also the question of what this means for the future of our universe. If we're inside a black hole, what happens as it evolves? Black holes don't last forever. They slowly evaporate through a process called Hawking radiation, where they lose mass over time by emitting tiny particles. For a black hole as big as our universe, this process would take an incomprehensible amount of time. Think trillions upon trillions of years. But eventually it could mean our universe would shrink and fade away, leaving nothing behind in the parent universe. It's a sobering thought, but it also makes you appreciate the fleeting beauty of the cosmos we're living in right now. Let's get emotional for a moment. If this idea is true, it means we're part of something so much bigger than ourselves. Every laugh, every tear, every dream you've ever had, it's all happening inside a cosmic structure that defies comprehension. It's like finding out you're a tiny speck in a grand, infinite tapestry, but that speck matters because it's part of the whole. It's a reminder that the universe isn't just a collection of stars and galaxies. It's a story, and we're all characters in it, playing our parts in a drama that spans billions of years and countless realities. But here's the thing. This idea isn't set in stone. Science is about testing hypotheses, and while the evidence is intriguing, it's not definitive. That study about the net rotation of galaxies, it only looked at a few hundred galaxies, and there are billions out there. We need more data, more observations, to confirm whether the universe really has a preferred spin direction. And even if it does, it might not mean we're inside a black hole. It could be some other quirk of cosmology we haven't figured out yet. The holographic principle, the matching densities, the similarities between our cosmic horizon and a black hole's event horizon, they're all clues, but they're not the whole picture. So, where do we go from here? Scientists are working on new ways to test this idea. One approach is to look for subtle patterns in the cosmic microwave background, the snapshot of the universe's earliest moments. If our universe formed inside a black hole, there might be tiny imprints of that event in the radiation we detect today. Another avenue is to study gravitational waves, ripples in spacetime caused by massive events like black hole mergers. These waves could carry hints about the larger structure of the cosmos, maybe even clues about a parent universe beyond our own. For now, though, this is a mystery that's still unfolding. It's the kind of question that keeps astronomers up at night, staring at their telescopes and scribbling equations on whiteboards. It's a reminder that the universe is weirder, wilder, and more wonderful than we could ever imagine. Whether we're inside a black hole or not, the fact that we're even asking these questions is a testament to the human spirit, our endless curiosity, our drive to understand the cosmos, and our willingness to confront ideas that shake the very foundations of our reality. So the next time you look up at the night sky, let your mind wander. Picture the stars not just as distant suns, but as part of a grand cosmic puzzle. Imagine that every twinkle of light, every swirl of a galaxy, is happening inside a black hole so vast it contains the entirety of existence. Feel the weight of that idea, the awe it inspires, the way it makes your heart race and your mind reel. And then keep looking up, because the universe is full of mysteries, and we're just getting started. If you're hooked on cosmic enigmas like this, dive into the latest research papers and telescope data coming out of observatories around the world. The universe is out there, waiting to blow your mind with its secrets. Until next time, keep wondering, keep questioning, and keep chasing the truth. wherever it leads.